Okay, before we tackle the division, there are just two things I'd like to mention. We don't usually do long division if our divisor is a monomial. We just go term by term. For example, if we had 3x squared plus 6x minus 12, all being divided by 2x, we would not do long division on this. We would just divide each term. It's kind of like the distributive property of division. Everybody gets divided by 2x. And that would end up, we'd have 3 halves of an x plus 3 minus 12. Dear, no, we wouldn't. We would have minus 6 over x. Sorry about the mess there. Let me get that out of the way. The other thing I'd like to mention is that division can be represented in at least 3 ways. One, and this is used a lot with documents because it's much easier to type this way. You take the one quantity divided by the other quantity. Or we can write the same problem as a fraction, and we'll be working with these in another couple units. Or you can do it the old-fashioned way, which is how we're going to do it today. All 3 of these represent the same problem. So we're actually going to be modeling all of our work after 4th grade problem, such as 52 divided into 2,971. Why not? Well, 52 won't go into 2. It won't divide into 29, but it will divide into 297. So our first answer is going to go right there above the 7. And we don't try to do the whole 52 at once. About how many times does the 5 divide into the 29? I'm thinking maybe about 5 times. Now sometimes the first guess is too large, but we'll give this one a shot. So I'm going to put the 5 up here where we said it should go. But now we're not really dividing by just 5, we're dividing by 52. So I'm going to have to multiply 5 times this entire 52 right here. Not just 5 times 5, but 5 times the whole 52, which I believe comes out to 260. And if you recall, our next step back in 4th grade is to subtract. So this subtraction's not too hard. And then bring down the next number and keep dividing. Once again, we're going to get an idea just by dividing the 5 into the 37. About how many times does 5 divide into 37? I'm thinking about 7. That might be too big. We'll find out. And we'll have to take 7 times the whole 52. So 7 times 2, 14, carry the 1. And again, subtract. Well, we ran out of numbers to bring down. We're not going to do the decimal and the zeros. We're just going to do this. So this is the remainder. But that's a remainder of 7 out of 52. So sometimes we wrote the remainder as a fraction. The entire quotient is 57 and 7 out of 52. And that's how we're going to tackle these. They're going to start off looking the same. We're going to put the divisor on the outside, the x minus 9. And we are dividing a lower degree into a higher degree. We can take 2 terms into 1 term. But we can take 2 terms and divide them into 2 terms. So our first answer is going to go up here above the negative 2x. So now we have to ask ourselves, what would you multiply times x to produce x squared? It's kind of like the 5 into the 29. So we have to take times x to get x squared. Well, we have to take another x. So I'm going to put that x right up here, right where we said it had to go. But now x isn't going to be just times x. We're going to have to take this x times the entire divisor. Just like up here, we had to take the 5 times the entire 52. So x times x is x squared. X times negative 9 is negative 9x. And then we're going to have to subtract, just like we did up here. I encourage you to use parentheses, because usually if people are going to make a mistake in these problems, they make it with a subtraction. Same thing happened back in 4th grade. Usually there was more of a mistake in the subtraction. So x squared, subtract x squared, they zero out, and they'd better. These first terms should cancel out. We're doing something wrong. And now we have negative 2x, subtract negative 9x. Which, if you remember, subtracting the negative is just the same as adding. So this will be like negative 2x plus 9x, which will give us 7x. Because the opposite of negative 9x is positive 9x. And then we bring down the next term and keep dividing. So now we're asking ourselves, what do we multiply times x to get 7x? Well, that would have to be a 7. And because it's a positive 7, we'll write plus 7 up here. And then multiply a positive 7 times the entire divisor. So 7 times x, 7 times negative 9, and subtract. Well, 7x minus 7x is 0. Negative 63 subtract negative 63 is like negative 63 plus 63. So this remainder is 0. That means this divided evenly, this is a factor. And not only is it a factor, so is x plus 7 a factor. And a lot of you could have factored this in your head, that x minus 9 times x plus 7 is going to give us this x squared minus 2x plus 63. So we got another couple to work on here. Okay, it looks like we have all our place values, a squared, a constant, a constant. And we're going to be taking, whoa, we're going to be smacking the document camera here. We're going to be taking these two terms, won't go into just one term. I'll take these two terms into these two terms. So our first answer is going to go over the 4a. To get a guess of what to write up there, what do we multiply times a to produce a squared? Well, that would have to be a. So I'll put that right up there where we said we were. And then we have to multiply this times the entire divisor. So a times a times 3, and then we subtract. It's divide, multiply, subtract. Well, a squared minus a squared, they should cancel out. And 4a subtract 3a is just 1a. Bring down the next term. And keep dividing. So what do we multiply times a to get 1a? Well, there is a number there. It is a positive 1. And now we multiply that positive 1 times the entire divisor, and we get a plus 3. The next step is to subtract all of that. Well, 1a minus a, they should cancel out. And now we have 8 subtract 3, which is 5. That's our remainder. That means this thing's not a factor. And neither is this one. So we can leave it as a remainder of 5, or we can write it as a fraction. Now this happened to be a positive 5. So we'll write plus 5 over whatever our divisor was, a plus 3. So our quotient here is a plus 1 plus the fraction 5 over a plus 3. It's not that bad. Moving on to number 3. Okay, this one's a little different because it's not just starting off with one n, we got two n's. And they're in the right order, and we're not missing any terms. We'll just go. It's all right. Two terms won't go into one term. We're going to have to take these two terms into these two terms. Our answer is going to go above the negative 5n. We're still going to find out what to put here by dividing the 2n into the 6n squared. What would you multiply times 2n to get 6n to the second? Well, that would have to be a 3, 3n. And now we're actually going to multiply that 3n times the entire divisor. So 3n times 2n is 6n squared. Then 3n times negative 1 is negative 3n. And we subtract. It's looking a little messy, maybe because of the way I write my n's. Well, 6n squared subtract 6n squared does cancel out like it's supposed to. And now we have negative 5n subtract negative 3n. Well, that's like negative 5n plus 3n. So the answer to the subtraction is going to be negative 2n. Because the opposite of negative 3n is positive 3n. With a negative 5n, negative 2n. Bring down the next term. And keep dividing. So we're going to be dividing 2n into negative 2n, and to produce a negative 2n from a positive 2n, we're going to have to multiply by negative 1. We're going to multiply the whole divisor by negative 1. So negative 1 times 2n. Negative 1 times negative 1 is a positive 1. And then we're going to finish it off by subtracting. Well, negative 2n subtract another negative 2n, they cancel out. Negative 7 subtract 1 is going to come out to negative 8. So we do have a remainder. This is not a factor. Because our remainder is negative 8, when we write the fraction, we would write it as minus 8 over 2n minus 1. I hope it's okay so far. We have only one more. So we're going to be dividing by the quantity k minus 4. And before I write the problem down, and the others, we did check to see if everything's in order. Well, we've got a constant. We have a k, and then we have a constant. But right here, there's a gap. This went from 6 cubed, that wasn't a mistype, as I usually do. That was supposed to be k cubed. It went from k cubed down to just 6k. We are missing, we have no k squared term. And we need a k squared. So we're going to fake it in. We're going to put a 0 k squared in there, which I know looks like okay. But so this is going to become k to the third plus 0 k squared, and then the minus 6k, and then the plus 1, because we have to have every place value in there. All right, doing two terms, going to have to do into two terms. The first answer is going to go over that 0k squared. Well, what do you multiply times k to get k to the third? Now that's going to have to be k to the second. I'll put it right there where we said it would go. And then we're going to have to multiply that k to the second times this whole divisor. So k to the second times k, that's k to the third. K to the second times negative 4. And then we subtract. Well, k to the third subtract k to the third, they go away. 0 minus negative 4 is going to be 0 plus 4. So we're going to have a positive 4k squared here. Bring down the next term. And keep dividing. So what do you multiply times k to get 4k squared? Well, that would have to be a 4k. And it's a positive 4k we need. So I'm going to write plus 4k here. And then we multiply a positive 4k times the entire divisor. 4k times k. 4k to the second. 4k times negative 4. Negative 16k. And then we subtract. Well, the 4k squares very nicely cancel out on us. Negative 6k subtract a negative 16k. Well, subtracting a negative 16 is really the same as adding 16. So this would be like negative 6k plus 16k, which is going to come out to 10k. Bring down the next term and keep dividing. So we're going to divide k into 10k. Well, you need to multiply by a positive 10. So I'm going to put a plus 10 up here. And then multiply 10 times the divisor. So we'd have 10k minus 40. Which we're going to subtract. The 10k's cancel out. 1 minus negative 40 is the same as 1 plus 40. So our remainder is 41. It's a positive 41. We could write it as plus 41 over k minus 4. And that would be it.